My name is Donghee Lee. I'm from South Korea, from Kookmin University. I will introduce my poster, and let me show you. Our interested in about biotransport, and this is our motivations. This is the picture of a peritoneal dialysis. People who have renal failure have conducted peritoneal dialysis to remove the waste in the blood. So many people conducted this method. However, more than 5 years of peritoneal dialysis, peritoneal membrane become altered like this. So solute transport become changed. So it is important to know about the solute transport through the membrane. So many doctors use this method, peritoneal equilibrium test. However, this PET test takes too long time, and it can only measure the transport phenomena about creatinine and glucose. However, there are actually many molecules in the blood. So we developed the fiber optic based flap techniques to measure the diffusion of solute transport across the peritoneal membrane. So this is our technique. This is very conventional method to measure the motility of a protein in cell. However, we modified this method by using fiber optics like this. This is our experimental setup. And we selected NAF as a surrogate marker for relative diffusion of glucose, because in dialysis there are much glucose in the dialysis. So they have similar kinetics, so we choose the NAF. So this is the procedure of our experimental setup. We anesthetized the rat and we injected NAF solution to the tail vein of the rat. And after we opened the abdomen of the rat, we injected the dialysis. And we measured diffusion of NAF in the peritoneum of the rat like these procedures, and we can automatically obtain the curve. From this method, we can obtain this fluorescence recovery curve, and we can calculate diffusion coefficient. So we validate our method in vitro study. So as you can see, larger molecule diffused very slowly. And this is agar gels. Small agar gels which have small pore size have small values. And we apply this technique to the rear peritoneum of the rat. We hypothesized that peritoneum on each organ have different characteristics. So solute transport will be altered according to the organs. So we measured diffusion of NAF through the peritoneum on each organ, so like liver, cecum, kidney, and stomach. The diffusion coefficient of NAF are different according to the organs, and however they have very small differences. And during the peritoneal dialysis, diffusion of molecule becomes altered according to the time scale. So we measure the diffusion coefficient in different organs and different time scale. And we found that diffusion coefficients are really similar according to the time in peritoneum of the cecum. However, diffusion coefficient of the solute become drastically increased in the peritoneum on the kidney. So we think that the kidney is relatively vulnerable to the dialysis, and in the further study, we want to measure the diffusion coefficient of NIF in abnormal peritoneum and each organs and according to the time. And we collect the data, and we want to use this data in the clinical treatment of the patient. I think this method will be very useful for the measure the transport phenomena in deep tissue. Thank you very much.